Yeah, so before we begin, a little bit of an introduction about myself. So I'm a senior technical account manager at HashiCorp. It pretty much means that I work with our enterprise customers, so anyone who buys the enterprise versions of our products, I kind of work with them. I talk about the roadmap. I work with any kind of support issues they're having troubles with. We talk about architecture. I work with most of the other teams. Hence the name of my team, Customer Success. I'm not successful if my customers aren't successful. And testing is just one of the things that seems to come up a lot, so I thought I'd talk about it. So yeah, I'm based in London in the UK, and I've been at HashiCorp since 2018. And yeah, this is my second time in Vilnius. I spoke at DevOps Pro back in March, so it's good to be back. So let's get more detail about what we're here to talk about. So we're here at TestCon Europe 2019, so probably pretty important that we should talk about the test part of that. And I'm going to be talking about infrastructure as code. It's a pretty big thing that's been happening sort of the last decade or so. Before I worked at HashiCorp, I worked at Puppet, and before then I worked in the UK government space doing some sort of sysadmin stuff. And infrastructure as code is like a really big deal these days, so I thought I'd talk about testing it. And what does infrastructure as code mean? Essentially, it's basically treating the tooling that you manage your infrastructure in the same way you treat any other code, which kind of makes sense. And what are the benefits of doing that? So most of it is pretty much the same as the benefits you get from treating normal code like code. But the idea is that it's a lot easier to regenerate everything from scratch. You can kind of modularize and distribute and have things that you can pass along to other teams. You can use existing work that's out there. It's a lot easier to review and code review and kind of collaborate on infrastructure as code rather than telling someone, okay, log into AWS, click this button, follow these prompts and that kind of stuff. Having it as a code is a lot easier to kind of grok and keep in one kind of mental model. You can put in auditing and policies, which we'll talk about a little bit later. But the main thing, especially what we're here to talk about, is number 7, which is testing. So hopefully you shouldn't be asking this question, but some people do ask, why do we need to test this in the first place? And essentially it's the same as, why do you need to test anything? Ultimately, something like infrastructure as code, you're going to be deploying real cloud resources or API resources anywhere, and testing's main purpose is to avoid that kind of niggling doubt you get when you're doing any sort of thing. When you're doing deployment of, doesn't matter if it's like an application or infrastructure as code or anything, there's always that little voice that's like, how bad is this going to be? Are we worried about deploying this? Are we going to push it off? Or are we going to wait till everyone's hands on deck? You're trying to remove that kind of worriedness kind of element that's going on. There's a pretty good quote from Devon, who is in the HashiConf Slack. I was talking about testing Terraform code then and kind of getting some feedback from the community about it. And he basically put it as infrastructure as code without testing to me is self-sabotage, which is a little bit extreme, but probably pretty much the case for most people. So put your hands up if you've seen a table like this before in your testing lives. Yep, lots of hands up, which makes sense. So this is one depiction of the practical test pyramid. You've probably seen it before. The general idea is that as you go up the stack, tests are a lot slower, but there's more integration of all the various parts of your application. As you go down the stack, tests are a lot faster, but there's more isolation. And who here has seen this image before? A few less hands, but the idea is that what often ends up happening is that end-to-end kind of full integration tests are a lot more interesting. So what you have is a kind of anti-pan of the actual ice cream of reverse testing, where full end-to-end acceptance tests, because people can kind of visualize them, especially if it's something like a Selenium test that's, clicking things and doing things in real time, people kind of get more reassured. They're like, oh, yes, I can see what it's actually testing. So inversely, people end up writing a lot more of these tests and kind of ignoring the unit tests, and we want to avoid this. And ultimately, this is what often ends up happening with something like Terraform or any infrastructure as code, is that people's testing is basically defined as like, I tried it, I ran it, it seemed to be okay, let's just ship it, which is definitely something we want to avoid. And yeah, we're going to be concentrating on Terraform, but most of the concepts that I'm going to be talking about would apply to any infrastructure as code. So, something like CloudFormation or Puppet or Chef or Ansible, anything really would kind of work in the same way. So what's the most simple test you can do? Well, the most basic for most languages, and the same with Terraform, would be some sort of compilation and linting. So depending on who you talk to, do these really count as tests? Probably not. They're more of a kind of health check kind of thing, but it's probably something you should be doing in your kind of CI/CD pipeline anyway. So Terraform has the idea, it's a language that you can then interpret. We have actually done a lot of work in the latest, good question I should probably ask here. Who here is using Terraform in some way? Lots of hands. Who here is using Terraform 0.12? Few less hands. But, so one of the cool things that's happened is the Terraform 0.12 was kind of our big kind of refactoring of a lot of the code. And one of the cool things that we had in these new features is basically that we have much better error messages now. Because before there wasn't some formalizations in the language. When there was an error, it wouldn't tell you specifically how to solve it, or sometimes it wouldn't tell you the right line because the language wasn't in such a good way. All of the changes that came in 0.12 means that we're a lot more prescriptive about the errors. Like for example, in this one, you can say, oh, the blocks of type tags, it's not expected. Did you forget to put an equal sign in there? I put the equal sign in, everything goes great. So that's the first step. This is the most basic way of testing your Terraform, is doing what it's supposed to do. Then we have tf-lint. So there's no official linting tool, but someone basically wrote one. Right now it's concentrated mostly on the AWS provider, but I think on the GitHub for it, he's got a pull request open for a kind of plugin system. And the idea would be that each provider would have its own set of linting tools, just like anything else, just like Robocop or anything like that. And this works in the same way. It can actually do a little bit of linting on code, and you can start writing your own rules as well. So it's pretty cool. Okay, so we are thinking about the pyramid. So let's go for the bottom part of the pyramid. Let's go for the unit tests. One definition I like to talk about when differentiating between unit tests and acceptance tests. Acceptance tests are for testing you're building the right thing. Unit tests, you're making sure that you're building the thing right. And that's what we want to think about when we're writing these tests. So funnily enough, I've kind of worn a lot of hats in my time. Right now I'm in a post-sales kind of customer engagement role, but previously I've been a developer, I've done QA, I've done sysadmin. So talking to some of my kind of QA testing kind of colleagues, some of them who are into the world of infrastructure code and some not, I kind of asked them and said, like, do you consider these unit tests? And do you consider these acceptance tests? And there was a little bit of like, not sure specifically. You know, especially because you're talking about a language that then compiles into something else. Would anything that actually tests the language be actually acceptance test because it's actually creating real things? And yeah, there was some disagreement around that. The text is a little bit small, but the only real unit test you could really think about would be Terraform has the idea of a provider. A provider is when you write down how Terraform itself interacts with a various API. Those actually have unit and acceptance tests. For example, in this one, we're testing that you can't actually give an invalid name to an AWS API element. So the idea is that obviously the Amazon API will tell you this if you try to do it anyway, but we capture that earlier in the stack. So this is the only real Terraform unit test. But we're going to talk about how you can unit test the language itself. So we kind of fall into the first hurdle. But to kind of make sure that we're not falling into that, is this not an acceptance test, we're going to use some slightly different terms. So for people who are not aware, Terraform has this idea of code and state. You write Terraform code, then that gets run by the Terraform binary, and that will check the current state of the code if it exists. If it doesn't, it will fetch what it expects to do. So it will then check remotely with the API, check what you've got locally, and then compare the two. So on the left, we have the code, and on the right, we have the state. So essentially, anything you're testing on the left is code testing. Anything you're testing on the right is state testing. So we're going to start using those terms to basically talk about the difference between code and state testing, with integration testing, which is kind of end-to-end testing on the top. So let's start with code testing. So there are a bunch of tools out there that do this. We're going to talk about a few. Again, these ideas are pretty much the same for most infrastructure as code, but I'm going to be focused on Terraform. So the first one is Clarity. Who here is a fan of kind of BDD or Gherkin style tests when getting done? Oh, cool, some hands up there. So this works in that way. It's essentially a binary. It's using a Go specific BDD language and then kind of converting it to Terraform, so it has its own set of custom matches. So it actually reads the HCL, which is the HashiCorp configuration language, which is what Terraform is made of. It then runs the matches that you want on it, and then it gives you output at the end, which means that you don't actually have to know any Terraform or even any Go to write these tests because they're purely written in Gherkin. So yeah, it's pretty cool. So example of this is a pretty simple one. We've got Terraform, given Terraform, and we have an AWS instance. We want to make sure that it's a T1 micro, and then there's only one of it. So essentially what we're saying here is that there's only one AWS instance, it's a T1 micro, and there's only one of it. And it gives you the kind of standard format you'd expect from some sort of Gherkin style language. Cool. And then there's Terraform Compliance. Pretty much works the same way, except it's a Python library instead. Has its own set of custom matches as well. Some of them are slightly more useful because it has kind of matches that are more prescriptive to common patterns that you'd have in Terraform. So when we talk about policy later on, one of the common policies that most people have is some sort of tagging policy. For example, even internally at HashiCorp, we have certain tags that have to be on your cloud things, because if you don't have those tags, we have a thing called the Reaper that will just go through and blow them away. The idea is that sometimes someone's doing a demo, they spin something up, they forget about it, it's just sitting there, you know, burning through money. So you have to make sure that you have certain tags and they have certain dates in them to make sure, you know, do not destroy after this date and that kind of thing. So you probably want to have some sort of test to make sure you have tags at all. So we have a pretty good example of that here. This time I'm actually using a Gherkin table, so I could actually add more examples if I want to do later on. So given I have any resource that supports tags, it has to have those tags. It should have the tags from the example table, and they should match a certain regex. So in this example, it's pretty simple. They should have a name tag, and the value should be something that's not blank. And lastly, the closest we have to actual unit testing would be something like Terraform Validate. So this is actually written in Python itself. This will do the same thing as the others. It will, this one's slightly different. It will take a plan output that you've created. It will then interpret that, and then you can start doing standard unit testing. But you have to write it in Python itself. So you need to have to know a little bit of Python knowledge and know about indentation and things like that. But ultimately, the test will look something like this. I actually made it purposely fail because the past test is just a dot with go, like, okay, one test went through. So in this example, I'm doing pretty much the same thing. I have an array of required tags. I'm making sure that a property should be there, and I have a property date. It didn't have that, so it failed the test. So one thing that comes up if you're a tester, you're kind of thinking about this, is that these kind of turn into tautological tests. If you have code and say, like, one AWS instance that has this type and this type, and you write a test that says one AWS instance that has this type and this type, you're kind of writing a test that tests itself. There's no point having a unit test that tests that true is true. You're kind of wasting a lot of time there. So what you really want to be doing is trying to test the edge cases. So for example, Terraform has the idea of input variables. So you probably want to have a test that tests that when certain input variable is this, then you have a certain result. That's more of a unit test that you'd be expecting. So generally you want to test the edge cases, and you want to test the negatives sometimes. For example, it must have tags. That's a pretty easy test to write. And who's familiar with the red-green refactor loop? Hopefully lots of people. Yes, good. So the idea is, because these unit tests are running quite fast and they're not creating any real infrastructure, it's quite easy to do a red-green refactor loop. And now we're going to actually have to give it a go. So I pull my terminal up here. Whoa. Where can you go that way? Come on. There we go. Sorry about that. Cool. So I've made some basic make tasks to do this. So if I do make clarity, we can see the same test that we did there. We do make Terraform compliance. Oh, Terraform init. Oh, something's going wrong there. So let's mirror these displays so I can see this a bit better. So essentially, the red-green refactor loop would look something like this. So first, I write the red test, something that's failing. There's no point writing a test that passes immediately, because then you don't know if the code you're writing is actually passing that test. So looking at our Terraform code, it's all pretty simple. Let's make sure that we have the right AMI. So let's go into Clarity. Let's do attribute and attribute AMI equals foo. We run Clarity again. Oh, I spelled attribute wrong. So it thinks this is not a step that's been implemented yet. There we go. But it's playing there. So yes, so then the test is failing. That's a red test. Then we go into our, this here. We change the test to the value that it's supposed to be. And then it's green. And then the idea would be, depending on the complexity of the test, for most BDD style testing, you don't have to do too much refactoring. But if you're doing, unit testing, and we'll talk about acceptance testing later on, you then go through the loop again, refactor, make it faster and easier, better to use. Cool. So the sort of pros and cons are pretty much as you expect. Pros, it's pretty fast, it's easy to write. Generally, you don't need an environment or credentials. I'm not actually spinning anything real up. But the cons are you're not really testing the real outcome there. So one of the things that we're talking about internally is something official and doing this officially, like maybe having a unit testing language written in HCL itself. There's actually a Terraform issue open for this, and one of the things we're discussing. But will this be happening anytime soon? Well, we do have a backlog of about 1,000 issues and 187 pull requests, so maybe not, but it is something that we're looking to the community to help out with. And in the issue itself, there's a lot of discussion there, so hopefully I can help out. So let's get into the more interesting bit, personally, I think, is the state testing. So the biggest example of state testing itself is probably the acceptance tests we have in the Terraform providers. So we're writing these providers for most of the big cloud vendors out there, plus API vendors and things like that, plus a bunch of community stuff that people have contributed. So we need to have a really good level of test coverage, because if someone's using, for example, the Azure provider, they want to know that it's been tested in all the various iterations and things like that. So the Terraform Testing SDK has some helper methods to do this. All of our providers have pretty much full code coverage, at least for the resources themselves. So this is not, this is just written in Go itself. These are within the providers themselves. You're probably not going to write this for your code, because it's more about isolation of particular providers, but you could do if you really wanted to. So for example, we've got this test just for testing a AWS instance. So all this is doing is it will create an instance, check that the volume is there and all that kind of stuff. So it's all pretty boring there. So on the Azure provider, every time someone opens a new pull request, we have an internal thing that will actually spin up and run the resource you've tested. So it will, there's some logic behind the scenes where when you do a pull request for a certain resource, it'll only run that test for that resource and then give you a passing or failing build. And the reason for this is because the full end-to-end suite of tests for most of the providers is pretty big. You're literally testing every single cloud resource that they have. For example, spinning up, I think, an AKS cluster in Azure takes about 15 to 20 minutes. So if you're doing that multiple times in multiple different ways, it can take a while. So you can see this is the full suite for Azure. That takes almost 10 hours. So we're not going to run that every time someone makes a change. But this is something that's running nightly. But when every someone opens a pull request, it will test that one bit of code for you. So the main thing that people are probably using is probably something called TerraTest. It was written by Gruntworks, who are a kind of consulting firm that do a lot of work writing reusable Terraform modules. A lot of their employees have done things like they've written the Terraform book. They've done a lot of work in the community. They've run a lot of tools to help out using Terraform, so it's really, really good. They use it internally themselves to test out large module deployments, and the same kind of thing. It has helper methods for testing that your Terraform is doing and what you expect. So there's a pretty good quote from Ben from the HashiCorp Slack. He was talking about this when I was asking about what people are doing for Terraform testing. And they've basically said that the return on investment is huge. You know, they've caught lots of regressions and problems thanks to the test that they're running. And then, as everyone knows, the earlier that you catch a problem, the cheaper it is to fix. You know, if you're doing a huge deployment of, let's say, a quite complex Vault cluster, and then you get to the end and you realize you made a problem, that might be a huge amount of resources, both human and technology that you've spent, and you have to start all over again. Way better to catch that in test. But he does mention that, similar to us, the full suite of tests can take a long time. So generally, they will test one test locally to do a little piece of it, and then the full suite will go on something like Circle CI and run, more of a cron job kind of thing. So here's a pretty easy Terraform example. We're basically doing a pretty simple test to test our AWS instance that I mentioned before. It actually runs the Terraform. It will see that running an init, running an apply, and then after that you can do tests to see if the thing works. And you're deferring the destroy, so after the test is done, it destroys the infrastructure. So let's do a little live demo on that. This is one I've recorded because you never know how the internet is going to be. So let's see if we can do TTY play. TTY record. Oop, is it working? Ah, no, that's the wrong one. Cancel that. Let's do make Terraform Terra test. So essentially, this is a wrapper around actually running Terraform itself. So most of the tools I'm talking about, there's nothing particularly unique about the tool itself. Most of it is kind of more like wrapping and foundations around things. But they've been battle tested. They have a lot of really cool features. So we generally recommend you use something like this than try and write something yourself, because lots of community around it. There's lots of things that have already been written. But essentially, you could do the same thing with a make file or some sort of scripting and do it yourself. So you can see we're actually creating real infrastructure with this. We're creating a micro server, AWS instance. We're then running some tests on it to make sure that the outputs are what you expect, and then we're destroying it. This is pretty quick because I purposely chose a really small instance, so a T1, and it's only going to take about 10-20 seconds to run that and then destroy it afterwards. And the test itself just looks like this. So after it destroy, run it in and apply, make sure the instance type is what we expect, which is T1 micro. Cool. So the whole thing took about a minute, but we have full assurance that the code we're writing is actually running a real Terraform run. So pros and cons. Pros, we're doing full end-to-end testing. It's the real way to assure that the things you're doing are what you expect. It's the closest to real testing. You're interacting with real APIs. There's no real way to know if your code is going to work until the rubber meets the road and it's actually hitting real things. So the cons, it can be slow, it can be costly depending on what you're spinning up, and depending on how you've kind of written your testing infrastructure, it can be interfering with real infrastructure. So you want to make sure you're not doing that. So maybe doing it in a certain region, or making sure that you've tagged your test resources different from your real resources. So lastly, integration testing. So I've kind of added a kind of blurred line between the state testing and integration testing here because there can be a lot of crossover. But essentially for me, when I think about integration testing when talking about Terraform, the integration step is testing anything outside of Terraform's direct control. So generally some sort of provisioning step. So not just testing that the resources are being created, but the scripting or the config management you've written is doing what you expect it to do, installing Nginx or whatever you're doing there. So provisioning itself is pretty hard to model a state, at least in Terraform's kind of world. And the best tools to do this are config management tools. So funnily enough, we don't consider Terraform itself a config management tool. We think of it more of a cloud infrastructure tool. So when people say something like, why use Terraform over Puppet or Chef or something like that, the answer is we're not saying to use Terraform over Puppet or Chef or anything. Those things are really good at config management. We think that Terraform is really good for infrastructure management. So. And that's actually, that's on our comparison page that we do for Terraform versus those two. So the main one I've seen to do this, again, you could do this yourself, but this is a pretty cool thing that someone's written called kitchen-terraform. It's a fork of TestKitchen, which the Chef team created to do acceptance testing on the Chef cookbooks. Essentially, it works in the same way. You have a driver, which in this case will be Terraform. It spins up the real thing, but in this case, it's actually going to interact with that infrastructure at the end. So it's kind of beyond the state, because it's not just testing the state as you expect in Terraform. It's actually going to physically SSH onto the box or talk to the APIs or do something like that. So in this example, you can see we're starting up Kitchen. We're running the Terraform code we've written. It then physically logs onto the box and uses inspec, which is a, if people are familiar with server spec, it kind of works in the same way. You write tests in RSpec language that will do tests on the system itself. So it will run something like uname and make sure that it's an Ubuntu box, and it will make sure that the release number is 1604. So this demo we can do a little bit faster because I pre-recorded it. I can even speed it up. So first you run converge to actually run the command to get the thing you want to test against. Then you run verify, and it will run the tests you've written. And mine are pretty simple. If I go, all I'm doing is describing the OS name as Ubuntu and the OS release 1604. I'm actually also, as part of the Terraform code, creating an AWS key pair that I then give to the test kitchen as a transport mechanism. It will then use that key to actually log onto that box and physically test the things that are supposed to be kind of there. So if I was provisioning this in some other way, using something like Chef or Puppet or Ansible, or even a shell script, then I could test it's doing what I expect it to do. So the last thing I want to talk about, it kind of sits outside of that pyramid because I'm not sure if there's a sort of equivalent in that pyramid, is policy as code and policy testing. So as we mentioned before, every organization has policies. So generally this will be something like naming conventions, tagging, price guides, whatever legal kind of boundaries you have internally. So we can actually reflect these as code, and then using that we can get the same benefits as you get when you talk about infrastructure as code as policy as code. So we have what's known as HashiCorp Sentinel. This is kind of an embedded policy as code engine. So the idea here is that you can write the logic that you would have generally on dead trees or in someone's head or in some sort of manual process when someone has to log in and check the things that you expect. And then you can use that as an actual policy and check that through. And this actually works for all 4 of our main products. So that actually works for Vault, Terraform Console, and Nomad. But we're going to concentrate on Terraform for the one here. So here's an example, something you probably have heard from your security team or maybe your networking team. You want to make sure that any AWS security group that you're creating doesn't have 000 egress. So you can't just create a box and then just have the entire public internet logging into it. So in this example, we're making a rule that says that all of the TF plan resources that are in an AWS security group, iterate through them, make sure that the egress does not contain 000. All pretty simple there. So let's see a little bit of this in action with a little bit of a cool feature that we have in Terraform Cloud. So this is the demo that's probably going to go wrong the most because it's using a real life service. So let's exit out of this. So who's familiar with Terraform Cloud? 2 hands and that there. So Terraform Cloud is basically our kind of SaaS version of Terraform Enterprise. And basically the idea is that you can use this as a platform to run your Terraform runs and then have things like RBAC and sign in and various kind of pipeline options. And we actually released it, we actually have a kind of free tier option. So if you want to go sign up, just go to app.terraform.io and then you can sign up for free and try it out. And then in the future, you're going to have a lot more easier kind of options for self-sign up for like kind of smaller paid teams. So in this example, I have the InfraCoding with Terraform for TestCon 2019, which is where we are right now. And then I can actually trigger a run and then see what happens. So let's trigger a run. Oh, let me discard this old one. So the whole idea of the kind of Terraform Enterprise run lifecycle is that everything has a kind of a lock file kind of thing. And so the idea is that you can only have one declaration of what the state should be. So every time someone does a trigger by opening a pull request or just triggering for the API, only one can run at once. Otherwise, you're going to have lots of things running over each other and conflicting things there. So we have a pretty simple plan here. So it's the AWS instance foobar. You can see it's saying that it's going to be created because we don't have anything existing. And you can see it's just one thing to add because it's a pretty simple test. So the cost estimation is going to queue. And then this is the feature we're actually going to talk about policy-wise. Because most companies probably have some sort of policy saying, we don't want to use these type of instances, or we don't want to go over this kind of level of costing. We have a new feature as part of Terraform Enterprise, which is basically a cost estimation. It will go through and it works with the most popular clouds right now. We're looking to do things like custom modeling in the future, but right now it basically looks at the instances that you have. It will do a delta of what the increase is based on the changes you've made, and it also will talk about the flat price of what it should be. So right now it's estimated that my hourly cost is only 2 cents an hour. The monthly cost is going to be 14 bucks, and the monthly delta is, because we've got nothing before, it's going to be an extra 14 bucks. So I have 2 policies running right now. It will block anything that has a provisioner in it, and it will block on anything that has a price increase. I'm not doing a price increase that are too much. So let's go through. I can then confirm and apply that. So I'll let that run in the background. So where we want to check that the InfraCoding. What we really want to test is that if someone tries to use a too expensive or make a too huge delta, that we can actually test that and make sure that it's working the right way. So we've got a pull request here. Let's spend some money and then let's delete that. Open a new pull request there. Oh, there we go. Let me just, in fact, let's. So we're going for a C5 metal, which if you don't know is like one of the most expensive instances compared to a T1 micro. So this is going to cost us a lot of money every month. So git add.git commit -m more money. While that's running, we can see that our apply finished. So we've actually created a resource and everything's gone through correctly here. So now we've got this new pull request that's gone up. We can then open a pull request here. And this is hooked up to the workspace that we've created. So if we go into here, we can see the run that's being run. So this is going to do a plan. It should be destroying the original and creating it with a new instance. So we can see that it's going to, one thing is going to change because the instance type is going from micro to C5 metal. So this plan's finished. And the policy check has hard failed. So we can see that the proposed monthly cost is going to be $3,000, which is over our limit of 1,000, and the increase is over a percent change of 10%. As you can see, it's well over 10%. So the policy I can see in my workspace, if I go here, and I go to settings, I go to policies, and I go to block price increases, Essentially what it will do is it will go through, do some decimal checks, make sure that the cost you've got from the estimation is over what you expect, and then it will block that. And we can also set that to be hard mandatory, so it's a full block, no one can make a change to it. Soft mandatory, so an admin can go through and say yes or no, or just a warning. So maybe you can have something to say, hey, just so you know, this is going to cost a lot of money. Cool, and that's policy checking. So what have we learned? We've learned the benefits of testing infrastructure as code. Regardless of the tool you're using, infrastructure as code without testing is basically self-sabotage. We learned how to do basic code and unit testing for Terraform, and how it's really beneficial to have a kind of quick feedback loop and TDD-style testing with red-green refactor. We've learned how to do state testing and how to test the final state, so using something like TerraTest to spin the whole thing up and make sure it's as you expect. And then how to do integration testing with something like Test Kitchen. So you're creating resources, but then testing the things that aren't directly related to Terraform, like something like a provisioning tool. And lastly, we've learned how to model organizational policy as code. So for example, if you have a policy not to spend over a certain amount or have certain tags, then you can cancel it from there. If you'd like to know more, the repo I use is live right now. You can go open pull request against it and see what happens. There is a pretty good blog post by Gruntworks themselves where they blogged about why they invented TerraTest and what uses it has. There's a about page for kitchen-terraform, and the actual official Microsoft Docs actually have a knowledge page about testing with TerraTest for Azure modules. And that's it. Thank you very much. And I think we have questions.